So starting with our chapter number system, the first topic that we're going to study in this chapter is types of numbers, right? Now types of numbers is not part of this chapter. You have already learned what are the different types of numbers in your lower classes. So if you do not know, please go back to your lower classes, please take your text, read it and understand what these type of numbers are, right? So we are going to delve into the chapter mainly from rational numbers and irrational numbers. This chapter mainly deals with rational and irrational numbers, alright? So this is just for your basic understanding. I'll be just giving you a short overview of it, which is not mentioned in your textbook, alright. So the first type of number is natural number. As you know, natural number, the first natural number is 1, then comes 2, then comes 3, and it extends till infinity, because we don't know what the last number is, right? Infinity means unknown, because we do not know what the last number in mathematics is, right? Now the second type of number is whole numbers. Whole numbers is signified by the letter W, right? Capital W, right? So W, what are the whole numbers? The first whole number is 0, as you can see. In the natural numbers, 0 is not included. In the whole numbers, 0 is included, right? So it starts from 0, then continues in the same manner, 1, 2, 3, etc. till infinity again, right? Now next type of numbers is integers. Integers, as we know, it is a set where we have all the whole numbers, 1, 2, 3, etc. till infinity, and we have the negative numbers, which is -1, -2, -3, etc. till minus infinity, right? And integers are shown by the set integers are represented by the letter Z, right? Now why do we use Z? Here natural numbers, the first letter was N, so we used N. Here whole numbers, so we used W. So for your additional information, this is not part of your chapter, this is just for your additional information. Z comes from the word zählen, okay? Zählen, which in German means to count, okay? So that's where Z comes from. Anyway, integers are represented by the capital letter Z, alright? So now keeping these information in mind, keeping all these things, natural numbers, whole numbers and integers in mind, let's start with our main portion of the chapter, which is rational numbers, alright? So, rational numbers. Now what are rational numbers? According to the definition of rational numbers are all those numbers which can be written in the form of P by Q, okay? All those numbers which can be written in the form of P by Q, where we have two conditions. What are the two conditions? The two conditions are that P and Q should be integers. Element of Z. Element of Z means what? It should be integers, okay? Or I can just simplify it and write P and Q should be integers. And Q should never be 0. And Q should never be 0. So what are the two conditions? The first condition is that P and Q should be integers. And the second condition is that Q should never be 0, okay? So now let's see some examples. Now let me take two integers, any two integers that you want. Now for example, I'm taking 1, okay? 1 is an integer? Yes, definitely it is an integer. 2, is it an integer? Yes, definitely it is an integer, right? So if I take 1 and -2, these are both integers. Now if I write it as 1 by -2, right? This is called the numerator. You have studied this in lower classes. This is called the numerator. And this is called the denominator, right? This is called the denominator. So now, as you can see, the denominator can never be 0. Q should never be 0. Why should Q never be 0? Because in mathematics, if you have 0 in the denominator, then that number is not defined. It is not defined, okay? That is not defined in mathematics. That the kind of number does not exist in mathematics, alright? So denominator can never be 0. So now look, I have taken any two random integers, and with that, if I make the ratio, if I take a division of both, then I can see that I can form a rational number. So some more examples of rational number. Let's see some more examples of rational number. Now 1 by minus 2 is the first example that we saw. 1 by minus 2 is the first example that we saw. Now another number, minus 39 by 1, is it a rational number? Yes, definitely it's a rational number, because minus 39 is also an integer, 1 is also an integer, and it's in the p by q form, and one more condition is there where q is not equal to 0, it is 1, right? So this is an integer, and we have got a rational number, right? Now another rational number, example of another rational number, root 4, is it a rational number? Yes, definitely it is a rational number. What is the root of 4? Root of 4 is 2, right? Root of 4 is root 2 square, root and square cancels itself and we get 2, right? So now 2, how is it a rational number? How is 2 a rational number? It cannot be written in the form of p by q, right? You might be thinking there is no q here, right? But it can be written in the form of p by q. How can it be written in the form of p by q? 2 can be written as 2 by 1. Any number can be written as a numerator of 1, right? So 2 by 1. So as you can see, 2 is also an integer, 1 is also an integer, and we have 1 below, not 0. So that means 2 is also a rational number. So any type of number that can be written in the form of p by q. See, for example, all these examples that I am writing right now, these are all rational numbers, yes or no? 35 by 5, 7 by 8. Any number that I have written here is a rational number. You can make numerous numbers. So now, keeping in mind what rational numbers are, we are going to see what irrational numbers are. Now this is what's most important part of this chapter, okay? Irrational numbers is the most important part of this chapter. Now, what are irrational numbers? Let's see. Now, before studying what are irrational numbers, as you can see, the name itself suggests irrational, right? Now what is irrational? It's obviously all those numbers which are not rational are going to be irrational, right? Now how do we understand, when we look at a number, how do we understand whether it's a rational or irrational number? We can understand it after studying all these things that I'm going to tell you, okay? So listen carefully. Now the first point that we need to know is that every number has a decimal expansion, right? Now what is a decimal expansion? Let's refresh your memory. Now look at this. 2.5, is it a decimal number? Yes, it is a decimal number. How did you identify that? Because there is a decimal point. There's a decimal point, right? There's a decimal point. This small dot is called the decimal point, right? I hope you all remember, right? Yes, so this is a decimal point, so this is a decimal number, right? Likewise, any number in maths can be represented using a decimal expansion of that number, right? For example, let me take some different types of numbers. Now 2 is a number, right? 2 is a number. So what is the decimal expansion of 2? 2.0. Whatever, when we have a 0 after the decimal point, it does not have any value, right? So which means I can also eliminate this, I can also omit this, right? So I can write 2 is equal to 2, so 2 is equal to 2.0. Can I write that? Yes, so 2.0 is the decimal expansion of 2, right? Likewise, if I write 1 by 2, what is the decimal expansion of 1 by 2? For that I need to divide it, right? What do I need to divide? This is called the dividend. You all know that. This is called the dividend, this is called the divisor, right? Yes, so we use the dividend divisor here and we use the dividend here while we divide, right? So now we're going to divide it. So 1 does not go into a table, so what do? We put 0 and we put a point, right? And as a result, 1 comes down and we can take 0 because there's a point, right? So this is 0.5. So we can see the remainder gets 0 and we stop it there. So 1 by 2 can be represented as what? 1 by 2 can be represented as 0.5. Yes or no? So what is the decimal expansion of 1 by 2? What is the decimal expansion of 1 by 2? 1 by 2's decimal expansion is 0.5. So likewise, whatever number I take in mathematics, I have a decimal expansion for that number. Any number can be represented using a decimal expansion, right? Okay, so next we are going to study the types of decimal expansion. Types of decimal expansion. There are 3 types of decimal expansion. The first type of decimal expansion is called terminating decimal expansion. Now what does the word terminating mean? Terminating means something that stops, right? Terminating means it stops, right? So yes, so the decimal expansion which stops after a particular number or a particular digit is called terminating decimal expansion. Now let's make it more clearer by taking some examples, right? So now the previous example that we saw, 2 is equal to 2.0, right? And 1 by 2 is equal to 0.5. Can you see that the decimals are stopping after a particular time? See, there's no continuous other numbers, right? So that means it is terminating after some decimals, right? It is terminating after some numbers. So this is called terminating decimal expansion, okay? Suppose I take another example, suppose 17 by 2. Now let's see 17 by 2, is it a terminating decimal expansion? Let's see. 17 by 2, when I divide it 17 by 2, 2 8s are 16, 1 0, 0.5, 10, 0. So that is 8.5. That means 17 by 2 is how much? 8.5. So you can see that there are no more numbers this side, right? The decimal expansion is stopping or terminating. So this is called terminating decimal expansion. So the second type of decimal expansion that we are going to learn is non-terminating decimal expansion, okay? Non-terminating decimal expansion. Now what is non-terminating decimal expansion? It is the opposite of the other one, right? Non-terminating decimal expansion, it is the opposite of the other one, right? So non-terminating decimal expansion, are there two types of non-terminating decimal expansion. Now let's see the first type of non-terminating decimal expansion. Non-terminating recurring decimal expansion, recurring or repeating. Now what kind of decimal expansion is this? Let me explain it to you using an example. Now look here, the first example that I am taking is 10 by 3. Can you see 10 by 3? Yes, so 10 by 3. Now let's divide it and find it out. 10 divided by 3. 3 3s are 9. 1 0. So I take 0.3. 9 again. So 1 0. Again I get 3. Again I get 9. And I can see that the same manner it will keep on continuing. Which means I'll keep on having 3 here multiple number of times and it will keep on continuing. It will never stop, right? So as you can see, this 10.3 can be written as 3.333 etc. right? What does the etc. or the dots show us? It shows us that the decimal expansion never terminates. So it is called non-terminating, right? And then what does this repeating 3 show us? The repeating 3 shows us that the number that repeats itself is 3, right? So this type of decimal expansion is called non-terminating decimal expansion. So what is non-terminating recurring decimal expansion or non-terminating repeating decimal expansion? The decimal expansion where the number or the digit keeps repeating and the decimal expansion which does not stop is called non-terminating decimal expansion. Alright, so this is what non-terminating decimal expansion is, right? Now let's take another example and see. Let's take another example. (34 by 7). Can I take 34 by 7? Let's try. 34, 7, 7 4s are 28 and 6, 0, right? 7 8s are 56 and I get 4, 0. And I get 5, 0. I get 1, 0. I can take 1, 3, 0. I can take 4, 2, 0. I can take 2. Right? So I got 20. I got 14, which means I get 6, 0. So I can take 8. I can take 40, which means I can take 5, right? 35. So can you see one thing here? After 60, 40, 50, 10, 30 and 20, 60 comes again, which means that I'm going to get the same sequence. After 60, it's 40. Can you see that? After 60, it's 40. Then again after 40, it will be what? It will be 50 definitely, right? Because the remainder will keep repeating, right? So that's why we can say that this particular set of numbers, that is 8, 5, 7, 1, 4, 2 is going to repeat itself continuously and infinitely, right? 8, 5, I can say the next number by looking here itself, 7, 1, 4, 2, right? So it's going to keep repeating itself because we are getting the same remainders over and over, right? So this is what non-terminating, recurring or repeating decimal expansion is, right? So which means I can write this 34 by 7 as, what can I write this 34 by 7 as? 4.857142857142, etc. What does this dots show us? What does this etc. tells us? That it is repeating, that the same sequence of numbers, same set of numbers is repeating. So this is what non-terminating recurring decimal expansion is, okay? And so the third type of decimal expansion that we are going to see is non-terminating, non-repeating decimal expansion. Non-terminating, non-repeating decimal expansion, all right? Non-terminating, non-repeating decimal expansion. Now what is non-terminating, non-repeating? Definitely it's going to be the opposite of what we studied earlier, right? So the first type of decimal expansion was terminating decimal expansion. Now what is terminating decimal expansion? Terminating decimal expansion is the decimal expansion which stops after a particular number, right? It stops, it terminates, right? So the second type of decimal expansion was non-terminating repeating decimal expansion. What is non-terminating repeating? It does not terminate and the same set of numbers or the same sequence of numbers keeps repeating again and again, right? So that is what non-terminating repeating decimal expansion was. So now we are going to study the third case, which is non-terminating, non-recurring or non-repeating. What does that mean? It means that the decimal expansion does not stop and the sequence of numbers that repeats itself, the sequence of number that we get is not going to repeat itself, okay? The sequence of numbers that we get continuously is not going to repeat itself. In the first example, we saw that 3 was repeating itself again and again, right? So that was recurring. In the second example, we saw that the set of numbers 8, 5, 4, 1, 7, 2 was repeating itself again. So that was also repeating decimal expansion, right? So likewise, we are going to see a decimal expansion which is non-terminating, but the sequence of numbers does not come in the same sequence. It does not repeat in the same manner. Instead, we get different numbers each time. Okay, so that is what we are going to see. Now look, before we could take P by Q forms, we could divide it and we could find the decimal expansion, right? So now the examples that I am going to give you about non-terminating, non-recurring decimal expansion, I am not going to be taking the division and I am not going to show you because that is not part of our syllabus, okay? You just need to, the only thing that's part of our syllabus is when you are given a number, you have to identify whether it is a non-terminating recurring, whether it is a terminating decimal expansion or whether it is a non-terminating repeating decimal expansion or not, okay? So for that purpose, you don't need to divide it and find it out, and plus the example that I'm going to show you right now is for higher classes, and not only that, we are going to be using a different method called long division in order to find out the decimal expansion. So that is not needed for yours, okay? So just the example will be more than enough, okay? So now there are numbers called, there are different numbers like root 2, for example. Root 2, is it a number? Yes, definitely it's a number. And when I look at root 2, when I see the number inside 2, 2 is not a perfect square, which means I cannot remove the root, right? It is not a perfect square, so I cannot remove the root, which means that root 2 I need to find the calculation using a special method called long division. Okay, there are different types of methods. You can use any method to find it out. So when I find it out, I get that the decimal expansion is 1.41421362373009, etc. Okay, etc. And what does this mean? Can you look at this number 41421356237309? Can you see that any of the number is repeating? No, it is not repeating in any sequence. It is not repeating in any particular orderly manner, right? So that is why this type of decimal expansion is called non-terminating, non-repeating decimal expansion. Now look here, it is not terminating, it's keeping on continuing, it's going on and on. Yes, these dots show us that it is not stopping, it keeps going on and on. The division will continue forever, but the set of numbers that I'm getting is not of the same type, it's not of the same sequence, it's always different numbers, right? Different numbers. That does not mean that the same number cannot repeat. Now look here, 4 and 4 is repeating, but can you see that 414, 414, 414 is repeating? No, it's not repeating. Or 4141, 41 is repeating? No, it's not repeating. Or after a particular point, 35, if I take 35, 35, 35, is it repeating? No, it's not repeating. So which means that when I look at the decimal expansion, it is not stopping, it is not stopping, so it is non-terminating. And also the set of numbers is not repeating in a particular sequence, so it is non-recurring or non-repeating type of decimal expansion. Now another example I can give you is root 3. Root 3, again we'll find the value of this, we'll find the decimal expansion using another method which is not needed for you. So root 3, when I see the value of root 3, let me look at the value of root 3, 1.732050807556, etc. Okay. Now look at this. This is also non-terminating. Why? Because it is continuing, right? Etc. means what? It's continuing, right? So it is non-terminating, right? Now the non-repeating part, where does it come from? Look at the decimals, look at the numbers, look at the decimal and the numbers after it. None of it is repeating. Can you see that? 0 is coming here, here and here, but we have different numbers every time, and none of these numbers are repeating in a sequence. Every time I'm getting a different number, right, which looks different from the previous number, right? So that is the reason why this is called a non-terminating, non-recurring decimal expansion. So now to summarize whatever we have studied up until now, let's see. I've studied 3 types of decimal expansion. First I studied rational numbers, then I came into 3 types of decimal expansion in order to understand what irrational numbers are, right? So the first type of decimal expansion was terminating decimal expansion. The second type of decimal expansion is non-terminating, repeating or recurring decimal expansion, and the third type of decimal expansion was non-terminating, non-recurring decimal expansion, right? So what was the purpose of studying all these 3 types of decimal expansion? The purpose is to define what a rational number is and what an irrational number is, right? So in the previous section we have already seen what a rational number is, right? So now let's define what an irrational number is, keeping in mind all the knowledge that we have acquired until now. Let's see. All the numbers, okay? All numbers that I have taught you in the beginning, all numbers that have terminating and non-terminating all numbers that have terminating and non-terminating recurring decimal expansion. Okay, all the numbers that have terminating and non-terminating decimal expansion, okay, non-terminating recurring decimal expansion are called rational numbers. Are called what? Are called rational numbers. Okay, and all the numbers that have non-terminating, non-recurring type of decimal expansion, all the numbers that have non-terminating and non-recurring type of decimal expansion, okay, non-terminating, non-recurring, the last case that we saw, non-terminating, non-recurring type of decimal expansion is called what? Irrational number. Irrational number, right? So to summarize, what did we study? We studied first of all what was rational numbers, and then we came to different types of decimal expansion, right? We have seen 3 different types of decimal expansion. So based on the 3 different type of decimal expansion, we can say that the first 2 types, that is terminating and non-terminating repeating, are rational numbers, and the third type that we studied, the numbers which have non-terminating, non-recurring type of decimal expansion, is called irrational number. So based on that, which were the 2 irrational numbers that we saw? We saw that root 2 has non-terminating, non-recurring type of decimal expansion, and root 3 also has non-terminating, non-recurring type of decimal expansion in the example, right? So these 2 numbers are irrational numbers. Now in the next class, I will show you how to find out which number is rational and which number is irrational. Up until then, whatever knowledge you have gained up until now, please watch the video again and again, and please keep revising, okay, and be prepared for the next class. Thank you.